So, welcome back, friends, my dear students. So, today I start with binary file handling. It's just a revision of what you all have already done. And so we have already discussed on what a binary file is. So, again, we shall have a sneak peek over what it is. So, binary file, as we all know, as we have already discussed, in a binary file, data is stored in raw binary format. Okay. See, everything and anything on our computers are eventually stored in binary format only. Is it? I mean, everything at the lowest level is stored in binary format only, and that is how it is, right? And that is what is how data is being stored in a binary file. Fine. Now, what all types of data are stored in binary file? Like, what are those data types which are stored, or what are those files which are stored in binary format? So, any of the audio files, any of the video files, okay, your image files, your PDFs, okay, all of these are stored in binary format. Okay, now how is it different from what we have seen already? We have seen a text file, and it's very simple. In a text file, you open a text file, right? You just read the content on the text file. Even if the content's not there, you can start directly writing on the text file. That's not the case with a binary file. You open a binary file, but to actually eventually read or write onto a binary file or from a binary file, you need appropriate applications, and those applications aid to, correct, reading or writing from a binary file. Okay, until unless you have those applications, even if you open these files, you'll not see any readable content on it. You cannot see, you cannot write directly. It's not that you have, say, this is your okay, in just a minute. Yeah. So suppose this is a file, right? You click on it. It's a binary file. You click on it, you see the content. Say it's an audio file. I have just clicked on it and opened it, and I see certain content. There's some content on it. I cannot directly start using my keyboard and start writing anything on it, or I want to read from it. I want to get an audio content from it. I cannot do it directly by just clicking and opening the file. I need an application. Okay, until unless I have an application which serves reading and writing onto such files, I cannot do it. So we all know, for audio files we need certain set of applications, for video files we need certain set of applications, for image files we need certain set of applications. Okay, so this is a generic idea about what a binary file is. Now if I just look to a binary file, okay, with respect to what all we saw about a text file, see, the first difference that we see is that for a text file we don't need an application to read or write, but here we need application to perform reading and writing, okay, in a binary file. In a text file, if you remember, we talked of translations happening, carriage return translations happening. In a text file, end line is translated, okay, and accordingly the cursor moves on to the next line. No such translations happen in binary form file, right? No translations happen in binary file. Okay, even if there's a new line is stored in binary format, in raw binary format. Whatever translation is of binary translation is of new line, that is stored in the binary file. Okay, there's no translation happening. And now, because there's no translations happening in a binary file, they are faster as compared to text files. And because there's no new line, there's no translation to tab, there's no translation to space, no translations, only raw binary translations of these carriage returns happen. So hence, even the space occupied by a binary file for the same content is less as compared to the space occupied in a text file for the same content. Okay, so size is smaller, okay, as compared to for the same content in a text file. So these are few characteristics of a binary file in general. Fine. And yeah, now I will take in particular binary files in Python. Normally you will see that the binary files in Python have this extension .dat. Okay, like for txt normally we have this thing. For binary files we have .dat. So see, by now you have an idea of how to use a text file. What we any file, we open a file, we perform read or write onto the file. Now we are going to perform read or write onto the file would depend on what mode are we opening our file with, right? And we know what were the modes that we saw in a text file. We saw read, we saw write, we saw append, okay, and then we saw R plus, we saw W plus, we saw A plus. The same set of modes. We know what these are all about. Now the same set of modes are going to be for binary files like RB, WB, AB, RB plus, WB plus, and AB plus. And they work in a similar fashion as all these work. It's just that all of these work for binary files, or rather I would say when I work with a binary file, I need to use these modes. Okay, now, so you need to remember this. See, now I'll just take up two terms. One term is serialization and the second term is deserialization. See what happens. This is my Python file, okay? Say it's x.py and this is, say, my dat file, x.dat, okay? I name it y.dat, right? Say I have a list here with some content in it, right? What is list? It's a Python object. And if I write on this list onto this binary file, what happens is list is a Python object. To perform writing of this list on this file, it needs to be converted to byte stream. It needs to be converted into bytes rather, okay, into byte stream, and then only it can be written here onto the file. Likewise, if I want to read this list back from the file to my program, what is to be done? This byte stream is needed to be again converted back to the Python object. And what was a Python object? It was a list. So it gets converted to a list. So now see, this process of converting a Python object, okay, to byte stream is called serialization. And I just gave you all an example. If a list is to be written onto a binary file, it's to be converted to a byte stream. And if now a binary file is to be read and a list is being read from the binary file, so it's in which form? It's in byte stream form. It is again to be converted into list so that it can be used in this program. Okay, so what is deserialization? Deserialization is conversion of byte stream into my Python object. These two terms are very, very important and you all need to know, okay, the meaning of these. And it could be a list, it could be a dictionary, it could be a string, any Python object, okay. So deserialization is a process in which a Python object, okay, is converted to byte of streams, and deserialization is a process in which byte stream is converted into a Python object. Serialization happens when you write onto a file, deserialization happens when you read from a file. Okay, now next, see, obviously I have a file. What does that mean? Having a file means you read upon the file, from the file you write upon the file. So you need certain functions which support reading and writing onto the files. So for binary files, right, the two functions used are load and dump. Now the question arises, these two functions are from which module of Python? These two functions are from pickle module, okay, of Python. So whenever you're working with binary files, you need to import pickle module. and only when you import pickle module can you use these two functions. Load function is meant for reading from a binary file, and dump function is meant to write upon a binary file. Okay, now again I would introduce two terms here. The first one is pickling and the second one is unpickling. Now what are these two terms? Pickling is serialization, okay, and unpickling is deserialization. Again the same thing. Pickling is what? Pickling is conversion of a Python object to byte stream, and unpickling is what? Conversion of byte stream to Python object. And see, obviously now when you're writing onto the file, you're writing, it could be any Python object that you want to write on your file. So it first needs to be converted to byte stream and then only can be written upon the file. Likewise, when you're reading something from a file, say it's a list, it's not there as a list, okay, onto the file. It's there in form of a byte stream. So that byte stream cannot be directly used in your Python program. It first needs to be converted to a compatible Python object. And that in this case was a list. So it gets converted to a list and then I get it in my Python program. That's how pickling and unpickling work or can be explained. Fine. Next we'll see how to perform reading and writing on a text file. On a binary file. Okay, so the first line obviously is what? The first line is import pickle. Okay, import pickle. Now I'm doing what? I'm writing a list onto a file. Okay, we had taken example of a list, so let's take up a list. So first of all I take an empty list and now I'm going to create a list at runtime. Okay, and yeah, so while true, fine, and then I would do what? Okay, I would enter an element. Say I'm taking integer elements, right? Input, enter element. Okay, and what I do is I do l dot append ele, first element added. Okay, and then I ask again answer input another element. Okay, if you want answer written yy, obviously else would be n. So then what I check, if an is in, I would simply write this. Okay, then break. It means I don't want to further add any elements. I'm done. I've put it in a loop and as many as elements I want. Till then I'll be just giving yy, and the moment I give n, I break, I come out and my list is ready. Now what am I going to do? I want to write this list onto my file. So I need to open my file in which mode? Write mode. So first of all, I'd write f equals to open. Say my file name is x.dat. Okay, and which mode am I going to use? This mode, because I want to write on a file. See here, I want to tell you all one thing. Suppose your question says that the file already exists and you need to add, okay, something new to it. You need to add to existing data. Then you would use AB rather than WB. That depends on the question. Okay, so now I've opened the file. Okay, the file name is x.dat. Now what I need to do, I need to write upon my file. And what is that is needed to be written? This L that I've created. So what am I going to do? I'm going to write pickle dot dump. Okay, pickle dot dump. I need to write pickle dot dump because dump is a function of pickle module, and we all know that we need to fully qualify the function with the module name. And I would write L comma F. I'll tell you all one thing, a very common mistake that you all make is that you all interchange this at times. You write F here, L here. No, it's L comma F. And on execution of this line, what happens? This L has been written upon the file. You're sorted, and then you simply need to write F dot close. Okay, so this is how you write upon a binary file. Okay, next, just have a look and then I'll move on to the next thing. Now I'll just show you all how to read. I'll read the same list, okay, from the file. So the first thing that I need to do is I write again import pickle. Okay, import pickle, and again I take an empty list. Okay, even if I don't take it, doesn't matter, because I would read into L, so but still I take one, right? And then I write what? F equals to open, right? What am I opening? I'm opening x dot dat. Okay, and I'm reading, so I'll write RB. Okay, now I'd write L equals to F, sorry, pickle dot load now, because I want to read. And what am I going to pass? F. And now if I print L, I would get the list which I had written upon onto my file. And after I'm done with this, I would just close it. Okay, done. Now see, suppose there's a question in your exam. Okay, this one's very simple. Now there's a question in your exam that there's a list of structure, say this, say it is say, okay, roll number, name, marks, okay. So you have a list of this structure. So what you have to do is, first of all, writing, okay, this type of list onto a file is very simple. If I just see, as in my previous example, what I did, I took element. Here what am I going to do inside the loop? I'll enter value for roll number, I'll enter value for name, I'll enter value for marks. I'll do all this in a loop, okay, and finally I get the L and I dump it. So this one's ready. Now the next part of the question would be, write a function to display, okay, the names of the students, those who have scored, okay, above say 85. This is the question. So now we'll see how to do that. Okay, I'll just take up this example. Now suppose, yeah, so the first thing that I'm going to do is import pickle, right? And yeah, say this is my empty list, and I do what? I write, yeah, F equals to open, say my file name is x.dat, whatever is given in the question, and I'm going to read, okay, and then what am I going to do? L equals to pickle dot load F. Now see, in this L I have a nested list, okay, in which roll number, name, marks, roll number, name, marks, roll number, name, marks. Okay, I have a list like this. I have to display names. I have to display name. Name is on which index? First index. Of marks, which is on second index, which is greater than, okay, 85. And this is which index? Second. Okay, so now what am I going to do? I will traverse this list. I'll write for rec in L, correct? First iteration, I have the first record with me, okay, and I want to check if rec2 is greater than 85. Why 2? Because marks is on second index. Okay, so I'm checking rec2, and rec is what? Rec is the first record, first iteration, first element of the list. Second iteration, second element. Third iteration, third element. And every element, marks is second index and name is first index. So if rec2 is greater than 85, what I need to display? Print rec 1. If the question says you need to display roll number also, you would write reg 0. Got it? Now this is how you do a question wherein you read, okay, and then after that you search based on a condition and you display. Getting it? Now I'll just take up one or two more questions, okay? Or before that, I'll just do one thing. I'll take file pointers before that, okay? Yeah. See, in any file handling this thing, or I would say whenever you're working with a file, there's something called a cursor, okay? I told you all while I explained modes, okay, of a file, I told you all that the position of the cursor depends on in which mode you're opening a file. If you're opening a file in, read mode, your cursor is at the beginning. You're opening in the write mode, the cursor is at the beginning, okay? Say this is your file. And if you are opening in append mode, the cursor is at the end. And whatever you do, if you obviously append is for writing. If you intend writing, it starts from here, okay? So the cursor position plays a very important role on how the data is going to be picked, okay, from the file, read from the file. Where see, it's very much similar to you open a Word file, okay? Say this is my Word file, okay? And in my I probably have content here in this Word file, doesn't matter. My cursor somehow is here. I have opened this file, okay, and my cursor is here and I start writing. So writing is going to begin from here, okay, because my cursor was here. So depending on the position of where the cursor is onto the file, reading, writing happens accordingly, okay? Now we'll see how we can manage, okay, where our cursor is to be positioned, or if we want to know where our cursor is, we have two functions, okay, which help us in deriving the position of our cursor as well as positioning our cursor, okay? And the two functions are tell and seek, okay? What does tell function do? It returns the position, current position, right, of cursor. And what does seek position do? It seeks or brings to the desired cursor position, okay? By default, when you open your file in read mode or write mode, where is your cursor? It's at the beginning. And in that case, one more thing, it returns the position of cursor in bytes. This is important, in bytes. Now, suppose I have a file, okay? This is my file. I open this file, say it's again x.txt, okay? I open this file. As soon as I open this file in read mode, where is my cursor? My cursor is here, correct? In this condition, if I print f.tell, what am I going to get? I'm going to get 0. Why? Because my cursor has not yet moved from its initial position, and initially my cursor is at the beginning of my first byte, that is 0th position, okay? Now what I do here, say I write f.read 1, means what? I'm reading one character. The moment I read one character, I'll just do one thing, I'll just take an appropriate example here so that you can understand, right? Yeah. Say this is my file which has hello India, right? Yeah. Now, initially my cursor was here, okay? Now, I had told you all this while doing text file as well, okay? But I'm just repeating it. So, initially my cursor is here, and so when I ask tell me where the cursor is, it gives me 0. Your cursor is at 0th position. Fine. After this, I perform this read operation with 1 byte, okay? So, it just reads one character, and my cursor now moves to which position? Now my cursor moves to this position, okay, from here to here. Now if I again write print f dot tell, right? What am I going to get? I'm going to get 1. Got it? So every time, next time, if I again write f dot read 2 more characters and I repeat this line, print f dot tell, so it is again advanced by 2 characters. So where is its position? See, where is its position? It was here. Okay, one more, it is here. Then one more, it is here. Now if I ask it using tell, what am I going to get? 3 advances. So I'll be getting 3. Okay, it has read 3 characters. So it is at the end of 3rd character now. Okay, it is at end of 3rd character. I'll get 3. So this is how we can use tell. You know, in your exams, you get an output question based on seek and tell as well. So you should very clearly know how seek works and how tell works. Okay, you need to very, very clearly understand. Fine. Now, so this is about tell. Now I move on to seek. What is seek doing? Seek is giving me a position. It's giving me a position, right? Giving position to my cursor on my file. Okay. Now, suppose I just start with an example only. Suppose I write f dot. I'll explain further, but I just start with this 0. What does this mean? It means seek 0th position. So wherever the cursor is on the file, it would just move to, say this is the file, it'll just move here. It'll just move here. Okay. Wait, I'll just again take the same file. Say this is my file. My content is hello India. Okay. So, seek 0. Okay, by default also my cursor was at the beginning. And now I say f dot seek 2. So where is my cursor going to come? It's going to come to this position. Okay, second byte, after second byte. Seek 3 after 3rd byte. Okay, this is how it moves. Now see, here I am giving absolute values. I am straight away saying that place the cursor at this byte position. But there might be a possibility that my cursor is at a certain position and I want to make it move either in backward direction or forward direction. It's not always in this direction only. Might be it's at the end I want it to come backwards. Okay, might be it's somewhere in between I want to go make the cursor move this side or that side. So I need relative movement of cursor also possible. So for that we use offsets as well, right? So how it is, I'll tell you. It's like f dot seek. Okay, and yeah, I give an offset value and I give its position, okay, from where it has to. Yeah. Now, suppose here what all values can this take? I'll just tell you. Okay, position, offset. Now, offset can take 3 values. Okay, and it's very, logical. 3 values are 0. 0 means from beginning. Okay, 1 means current and 2 means end. Okay, now suppose I write, okay, f dot seek 3, 0. What does it mean? It means 3rd byte from the beginning. Okay, so where am I going to move? From the beginning, I move to 3rd byte position. So I'll just cross 1st, 2nd, 3rd, and at the beginning of 4th. Okay, now if I write f dot seek 3, 1, what does it mean? Wherever the 1 means current, wherever the cursor is at this point, it's at say it's at 3rd position, and I say further move, okay, 3. So it's going to further move 3 bytes, and from the current, it could be this as well. F dot seek, say it's minus 3 1. What does it mean? 1 means it signifies current position of the cursor. From the current position, go backwards 3 bytes. Why? Because it's negative. Got it? Because it is negative. So with 1, it can be negative as well as positive, because from current it can go forward, it can go backward. Okay, with 0 beginning, it has to be positive because it can only go forward. Now the last one is 2. Okay, now in 2, what does it mean? From end. Okay, so we'll just see from end. So f dot seek minus 4 comma 2. What does this mean? 2 signifies end. From end minus 4 bytes. So it's going to go backward. So for 2 you can have only negative value, because from 2 it can only go back, because it is saying end, it cannot go further. Okay. So this is how seek works. In a program you can get an output question wherein you can even get an MCQ on seek. So yeah, this is about tell and seek. It's really important you get at least a question on seek and tell as well. Now I'll just take few general questions. Just a second. Okay. Yeah. Just look at this question. Again, it's a binary file question, right? Just look at this question, this one. Yeah. A binary file salary.dat has structured. I just talked of this type of a question. Employee ID, employee name and salary. Write a functions countrec in Python that would read the contents of the file salary.dat and display the details of those employees whose salary is above 20,000. It's the same type of a question which you just did. Remember, function name should be same as that given in your question, right? If there's a name given, you have to write the same name like it's here. Okay. Now, because I have to count, I've taken a counter. I've opened my file in read mode because I have to read. Okay, exception handling. I write my entire content, okay, in try block wherever I expect an exception to appear. I'll take a session on exception handling as well, then you'd understand. But to keep it simple as of now, just focus. Okay, I've just done what I am, yeah. Okay, I'm printing emp ID with space. Okay, I mean, these are working as headings here because you're further going to print them. Now, pickle.load. What am I doing? I'm just loading. I'm reading. Okay, I get it. I get my record in rec, if rec2. Why rec2? 0, 1 and 2. If salary is greater than 20,000, I'm just displaying each of them. Got it? So every time, what am I doing? In loop, I'm reading each record, okay, and I'm displaying it. Here, see, what have I done? I've done the entire thing in a loop, not together, okay? One by one, I'm reading and I'm displaying. Now, next one. Here, a file contains information in following format, event.participant. Write a program that could read the contents from file and copy only those records from where the event name is athletics in the new file named athletics.dat. Again, what am I doing in this question? I'm reading as well as writing. See, the question says a file sports.dat contains information in a list in this format. Write a program that would read, first of all, read the contents from file and copy only those records from sports.dat where the event name is athletics in a new file. So what am I doing? I'm reading from a file and I'm writing selective content onto another file. That's why I have to open two files, one in read mode, one in write mode, right? Now try, I load it. Okay. If L0.lower athletics, I compare it with athletics. If it is so, I simply do what? I dump it into which file? F2, athletics.dat. This is a simple question. Okay. So we are done with our binary files as well. So now you need to practice as many as questions you all can. Done with text files. binary files, right? And now in the next class I'll be taking up CSV files, and then we would be done with file handling in Python. So see you all very soon.